This is question number 4, volume word problems, level 2 questions, workbook page 158. Now, in this question, it looks slightly different from the previous questions because now you see two different containers. Let's take a read. The rectangular tank, so can you see, identify which one is the rectangular tank? If you're not sure, look at the measurements. It says here 32 centimeter by 20 centimeter by 14 centimeter. So you can find that rectangular tank here. So this rectangular tank with the length of 32 centimeter, that's the length. Okay, and the breadth, that's 20 centimeter, and you have the height 14 centimeter, completely filled with water at first. So if you see this tank, does it look like it's completely filled? It's not. So that's the clue already. And this at first is a very important information. Some water, so what happened to some of the water? It doesn't look like it's full. Some of the water was poured into the empty cubical tank. So this is the next important word. Can you find a cubical tank? What does it mean by cubical tank? That means if that's the rectangular tank, this is the rectangular tank. It looks like the cuboid, rectangular. And it's cubical, that means it looks like a cube. With sides 20 centimeter each. Okay, looking at the indicators here, you can also see that the clue is here that for this rectangular cubical tank, the measurements are all the same, meaning I'm looking at a 20 centimeter length, breadth, height cubical tank. It's filled to the brim. That means completely full. Some of the water, this is the sum of the water, was poured. This is the poured part. Was poured into the empty cubical tank such that the cubical tank become full. Then here comes the important last part of the question. Find the volume of the water left in the rectangular tank. Okay, so previously we've talked about it. We said we could use the change of height to help us to target, to resolve volume problems of liquids. In this case, can we use the same strategy, changing height? Then we notice doesn't seem like it's possible. Why? Because we have two different containers. One's a rectangular tank and one's a cubical tank, and they have different heights. This one's the rectangular tank is 14 centimeter height. The base area is also different, so as the cubical one. Okay, then ultimately you see the volume of the water left in the rectangular tank. So with this key, you actually know that okay, to find this answer, I need to go with, instead of using the change in height, I need to go with tank at first, the volume of the water in the tank at first, minus whatever that was happened to the water, that means poured out. And this volume, this volume here is the cubical tank, and that will give you left. Okay, so that's the main idea. So here you see you have the volume minus the volume give you volume. So that's how we can work with perhaps not the height anymore but volume. So let's go with the steps. Okay, first find at first, volume at first. And volume at first, we are talking about the tank being completely filled. So this is the tank volume. Completely filled, length times breadth times height. The length is 32 centimeter times the breadth 20 centimeter. And we are talking about when it's full, the height of the tank when it's full is 14 centimeter. So this volume will be with some calculation of a certain number. Okay, please partition your work to do the calculations. I'll leave you to resolve that on your own. Okay, then we have the poured out volume. And this poured out volume refers to the volume of the cubical tank. This is the tank at first, so that is the rectangular one. And this is the cubical tank. So in this case, the length, breadth, and height is all 20 centimeter times 20 centimeter times 20 centimeter, which also give you a certain measurement in cubic centimeters. You have to calculate that answer. And finally, volume left in the tank will be the first answer here minus the next answer here, and you will get the final answer in cubic centimeters. Okay, pardon me for my handwriting, it's a little tough to write on the iPads, on the screen device, touch screen device still. But do remember, keep in mind, partition your own work, write in the way that's neat for you, such that you have enough space to do your calculations. Okay, and for your calculations, when we're doing whole numbers, do make use of the strategies. So in this case, I have 20, so I could count it easily. 32 times 2 first, which is 64. Then I have 64, and I have 640 because of the 10. Then I can just do 64 times 14. Then I put in the 0 again. And then you have 20 times 20 times 20. I could just ignore the zeros first. 2 times 2 times 2 is 8. So, and then we put the zeros in. You have 8,000 cubic centimeter. Then you put the do your final calculation of this number of the tank that you get from the first answer, and do your subtraction. Okay, so that is this question, question 4, page 158. Please get to the solution on your own.